Welcome students. All students are welcome to my chemistry class. Today I will discuss about hydrolysis of salts. At first we have to know which type of salts are hydrolyzable. Actually, the salts coming from strong acid, strong base do not hydrolyze. But the salts which are coming from weak acid and strong base, either weak acid or strong base or strong acid and weak base, these types of salts can be hydrolyzable. Suppose a salt like sodium acetate. We know the sodium acetate salt is coming from by the reaction of weak acid acetic acid and strong base NaOH. So this salt, when dissolved in water, is completely dissolved into CH3CO minus and Na plus ions. As CH3CO minus is a conjugate base of an weak acid, hence it is strong. That means it is a strong base. But as Na plus is the conjugate acid of strong base NaOH, hence it is weak acid according to Bronsted-Lowry concept of acid base. So Na plus does not react with water. There will be no reaction. But strong base CH3CO minus reacts with water to form weak acid CH2COH and OH minus. As it is a weak acid, so it is almost undissociated or weakly dissociated. So, due to the presence of excess OH minus, due to presence of excess AOH in the aqueous solution, the solution becomes alkaline. So, this is the explanation for the hydrolysis of sodium acetate in aqueous medium. Similarly, if we take another example which is formed from strong acid and weak base, that is ammonium chloride. So the salt is ammonium chloride. So it is a strong electrolyte. If dissociated into water, NH4 plus and Cl minus. So NH4 plus is a conjugate acid of weak base. So it is this conjugate acid is strong, but Cl minus, as it is a conjugate base of strong acid HCl, so this conjugate base is weak actually. So this reacts with water, but it does not react with water. So Cl minus does not react with water, but NH4 plus reacts with water to form weak base ammonium hydroxide and H plus. If you already have 2H2O, so you can write here H3O plus. This is weak base, so it are not distributed, almost undistributed. So, due to the presence of excess of H3O plus ion, the solution becomes acidic in this case. In case of ammonium acetate, water is ionized into CH3CO minus and NH4 plus. So it is coming from weak acid and as well as weak base. Relative reactivity of acetate ion and ammonium ion with water is almost same. So CH3CO minus reacts with water to form undistributed CH3COH plus OH minus, and ammonium ion similarly reacts with water to form undistributed ammonium hydroxide and H2 plus. As the reactivity are almost same, so the presence of H2 plus and OH minus ion almost same in number. Therefore, the solution becomes almost neutral. But in case of ammonium formate, in this case, the relative reactivity to some extent is greater in case of formate anion compared to ammonium ion. So, the number of OH minus ion produced from HCO minus into hydrolysis is greater than the number of H2 plus ion produced from ammonium ion. So the solution becomes to some extent alkaline. The solution becomes to some extent alkaline due to more number of OH minus are present in the solution. Similarly, in case of ammonium cyanide in water it is ionized into H2 plus and Cn minus. Both are coming from weak acid and weak base. Weak acid means weak acid here hydrocyanic acid, HCl, hydrogen cyanide, and weak base here ammonium hydroxide. But the Cn minus reacts with water to form HCl and OH minus. The relative reactivity of Cn minus is greater than, to some extent greater than the reactivity of ammonium ion with water. So, number of OH minus ion is greater than number of H2 plus ions in the solution. So the solution ultimately become to some extent alkaline. So in case of salts coming from weak acid and weak bases, we have to consider the relative reactivity of the cations and anions with water to form H2 plus and OH minus ion in the solution. Now I will discuss about hydrolysis constant. For anion, A minus ion in aqueous medium reacts with water to form H and OH minus ion. So hydrolysis constant pH equals to concentration of HA into concentration of OH minus divided by concentration of A minus. So this is equals to, we multiply both sides with H2 plus. So concentration of HA divided by concentration of A minus into concentration of H2 plus into concentration of H2 plus into concentration of OH minus. So we get into 1 by K into, this is Kw. Therefore, the hydrolysis constant pH equals to Kw divided by K. Similarly, in case of base, cation BH plus reacts with water to form B plus H2 plus. In this case, pH equals to concentration of B into concentration of H2 plus divided by concentration of pH plus. So you have to multiply OH minus here equals to B into H2 plus into OH minus divided by pH plus into OH minus. So get this is Kw and this is equals to 1 by Kb, that means Kw by K. So in this case, hydrolysis constant equals to Kw by K. Both cations and anions, so A minus plus BH plus water, you get HA plus B concentration of HA into concentration of B divided by concentration of A minus into concentration of BH plus. BH plus equals to concentration of HA divided by A minus into H2 plus into B BH plus into OH minus. So we ultimately get Kw by K into K. So for any salt, the hydrolysis constant equals to pH equals to Kw by Ka into K.